Hi boys and girls, so I'm going to go over the fourth 6 weeks review. We already did it together in class, but I'm just going to make a video of me doing the problems in case you forgot how do we do these problems again, what are the strategies. I'm going to go over it. So number 1 says, which expression is equivalent to 8 over 5? Okay, I'm going to do my cubes, always do my cubes. Circle my important numbers, so I have the fraction 8 over 5. Underline my question, which expression is equivalent to 8 over 5. Box in my keywords, equivalent. Equivalent just means equal or the same, okay? So they're asking us which expression, I'm also going to box in expression, which expression, so all of my answers, which expression is equal to 8 over 5, okay? So what I'm going to do is I'm going to add every single answer, okay? Now, if I look at A, I already know the denominators in A, they're different. I have 2, 1, and 2. If my denominators are different, we're not going to add that. We have not done anything like that. So A is automatically out, okay? If we look at the fraction that they're giving me, 8 over 5, I know my denominator is 5. And I know the denominator never changes. It will always be a 5. So I can already get rid of C, okay? So now I'm left with B and D. So now I'm going to add it. If I add B, like I said, denominator never changes. I have 4, 5, 6. So I have 6/5. If I do D, denominator never changes, and I get 1, 2, 3, 4, 5, 6, 7, 8. 8 over 5. So which one matches this fraction? It's going to be D. Okay. Next one, number 2, it says the model is shaded to represent one whole. So this is just one whole. Model C is shaded to represent a number greater than 1. So this is model C. Which expression cannot be used to represent this number? So again, I'm going to do my cube, circle my important numbers. I don't have any numbers in here. I'm going to underline my question, which expression can be used to represent this number? Excuse me. I'm going to box in keywords. So again, which expression and cannot be used. We're going to box in represent. Okay. So they're saying which one does not represent this? Well, first, before I even look at my answers, I need to know what does model C represent? Okay. So I'm going to look closely just at 1. I have 1, 2, 3, 4, 5. I have 5 boxes and only 4 are shaded. So my fraction would be 4 over 5ths. And I'm having that for 1, 2, 3. I'm having 3 of those. So 4 over 5ths plus 4 over 5ths plus 4 over 5ths plus 4 over 5ths. Okay, I'm just representing what these models are showing. That's all I'm doing. Okay, they all show 4 over 5ths. Now it says an addition sign in between them. So I'm going to be adding these fractions. Okay, again, the denominator never changes, and I just add my 4s. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 over 5, okay? So I need to keep that in my mind, 16 over 5. So now I'm going to go my answers, and just like the last problem, I'm going to add all of these, okay? So for A, if I add it, denominator stays the same. I get 1, 2, 3, 4, okay? For B, denominator stays the same. If I add it, I get 7, 14, 15, 16. For C, denominator stays the same. If I add all these, I get 16. For D, denominator stays the same. If I add all of these, I get 12, 13, 14, 15, 16. Okay? So back to my question. Which expression cannot be used to represent this number. So which expression does not have this number? The only one that doesn't have it is A. So my answer is A. Because the rest of them are all 16 over 5. Okay, number 3. Which fraction in the list below are equivalent? So I have all these fractions. So I'm going to do my cube, circle my important numbers, underline my question, which fraction in the list below are equivalent? Okay, equivalent, again, means equal or the same. And we're looking for which fractions in the list below are equivalent, are equal, okay? So if I look at my answers, they're comparing two fractions. If you remember, when we are comparing two fractions, we are going to do the strategy called butterfly. Okay, so that's what we're going to do. So for A, I'm going to cross multiply, that's the butterfly. So 4 times 6 is 24, circle it. 9 times 3 is 27, circle it. Because these numbers are not the same, that means that this is not equal. So this is not my answer. Okay, B. 3 times 3 is 9. 6 times 1 is 6. Again, these numbers are not equal, so this is not my answer. For C, I have 9 times 2, I get 18. For 3 times 6, I also get 18. These numbers are equal, so maybe it's my answer. D, 6 times 3 is 18. 4 times 3 is 12. Again, these are not equal, so this is not my answer. The only one that has the same numbers are C. It's equal. Okay, next one, it says Ahmed and Victoria are reading the same book. So far, Ahmed has read 5/8 of the book, and Victoria has read 1/2 of the book. Who has read more of the book? So I'm going to circle my important numbers. 5/8, 1/2. I'm going to underline my question. Who has read more of the book? I'm going to box in my keywords. So more, who, okay. And I'm going to box in Ahmed and Victoria. So it's asking who has read more of the book, Ahmed or Victoria. So I like to just draw everything out. I'm going to put A for Ahmed, and I'm going to put that he's read 5/8, okay? Then I'm going to put a V for Victoria, and I'm going to put that she's read 1/2, okay? I'm comparing two fractions. I want to see which is more. Okay, remember, just like the last problem, when I'm comparing two fractions, I'm going to do the strategy called the butterfly. Okay, so I'm going to cross multiply. 8 times 1 is 8, and 5 times 2 is 10. So now if I look at the numbers, I have 10, I have 8. Well, 10 is greater, so I know that Ahmed read more. So I'm just going to put a little note on the bottom and just put read more. Okay, so now when I go through my answers, I can say, okay, it has to be where it says Ahmed has read more. So I can already mark off A because it says Victoria. Can mark off B because it says Victoria. I'm down to C and D. Okay, it says Ahmed because, and then it shows shaded fractions. So for C, it shows 5/8, and it says that this one is bigger than 1/2. Okay, well, if I look at what I wrote, that's true. I put that since 10 is greater, Ahmed has read more compared to 1/2. Okay, so maybe C is my answer. Let me go to D. D says Ahmed because 1/2 is greater than 5/8. Well, if I go back on my picture, I didn't put that. I put that Ahmed read more because he has 5/8, and the number 10 is greater than 8. So it's not D. My answer is C. Okay. If it helps you too, you can also, once you figure out who read more, you can put your sign already here. The alligator eats the bigger fraction. That way, when you look at your answers, you can say, okay, my symbol has to look like this. Okay. Next one, it says Freddie has constructed squares, circles, and triangles from wire. He will use the shapes to make a wall hanging. Which expression can be used to find the fractions of the shapes that are circles or triangles? Okay, so I'm going to do my cubes. I don't have any important numbers, but I do have a question. Which expression can be used to find the fractions of the shapes that are circles or triangles? So I'm going to box in my keywords. Excuse me. Expression, fraction, and circles and triangles. Okay. So it wants to know about circles and triangles. Before we do anything, when we make a fraction of our circles and triangles, we have to have the denominator on the bottom. Okay. We have to have a denominator here. Now, this is where it gets a little bit confusing. It's asking for circles and triangles. So when we get our denominator, it's not the total of just circles and triangles. Our denominator has to be all of the shapes. Even though it's not asking for squares, I still need a denominator for the total amount of shapes. So I'm going to put that on the bottom. Denominator has to be total shapes. Okay, and I'm going to put that over here too. So I'm going to count all of my shapes. I have 1, 2, 3, 4, 5, 6 here. I have 1, 2, 3, 4 here. And I have 1, 2, 3, 4, 5 here. So if I count all my shapes, I have 6, 4, 5. So when I add these, I get 10, 11, 12, 13, 14, 15. Okay. So that means my denominator is going to be 15. This is my total shapes. Okay, so 15 here, 15 here. Now it's saying, what's the fraction of the shapes that are circles and triangles? So now I'm just going to look only at these. Okay. I know circles are 4, and I know triangles are 5. And it just wants to know which expression can be used to find the shapes that are circles or triangles. We're going to be adding these because we're combining them. Okay, so the one that looks like this would be D. So we're looking for an expression. Okay, so remember, when you do these problems, your denominator needs to be the total shapes. Even if it's not asking for it, you got to have all the shapes. Okay, next one says, which point on the number line represents a distance of 3/5 unit from 0? Okay, and we have our number line. So I'm going to do my cubes. I'm going to circle my important numbers, 3/5 and then 0. Underline my question, which point on the number line represents a distance of 3/5 unit from 0? Box in my keywords. Point, so which point, number line, represents, and then unit. Okay, so whenever you get a number line, you need to label it. You cannot just leave it blank. You have to label it. So when it comes to labeling my number line, I'm going to count to see how many of these lines do I have. And that will be my denominator, okay? So, for example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 lines. So that means when I make my fraction for each line, it's going to have a denominator of 10, okay? Now we go back to that word unit. Okay, if you remember, a unit fraction is a fraction that has a 1 on top. Okay, so I'm going to start with 1/10, and then next is 2/10, and then 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10. I know I did this right because remember, if you have a fraction with the same number on the top and the same number on bottom, that equals to 1 whole. Okay, so I did that right. So now I labeled my number line, but I still don't see that fraction 3/5. Okay, so we're gonna find out how we find that. So first I'm gonna label my fractions on my answers. So point Q is 3/10. Point R is 5/10. Point S is 6/10. And point T is 8/10. Okay? And so they want to know which point on the number line represents 3/5. Okay, so what I'm going to be doing is I'm going to be comparing 3/5 with all of these fractions. Because even if 3/5 is nowhere on here, there is a fraction on here that's equivalent to 3/5. Okay, we talked about how fractions can have different numbers but still be equivalent. So I'm going to write 3/5 on every single answer. And I'm going to be comparing the fractions. Remember, this strategy is called the butterfly. Okay, so I'm going to cross multiply. And I'm looking for which fractions have the same number when I multiply them. So 10 times 3, 30. 5 times 3, 15. They don't have the same number, so A is not it. B, 10 times 3 is 30. 5 times 5 is 25. They don't have the same number, so not it. C, 6 times 3 is 30. 5 times 6 is also 30. They have the same number, so maybe that's it. D, 10 times 3 is 30. 5 times 8 is 40. They don't have the same number, so no. So my answer is C. Okay, and like I said, even though 3/5 and 16/10 do not look alike, they don't have the same number, they are still equivalent. Okay, they are still the same amount. So just remember, when you get this problem, label your number line. Count how many you have.